12.3, cylinders and cones, 3 boxes plus an example. Let's move up to there. So let's talk about the parts of a cylinder. So we've already explored the physical cylinder that I've showed you guys. The parts that we need to be responsible for is one here on the side here. Okay, this part right here that I'm highlighting for you. This part over here, can you guys see that, the highlighted part? Yeah. Okay, that is what we're going to call the altitude. Yep. The altitude or the height. Right there, the altitude or the height. That's that part right there. The other piece of the cylinder we need to be responsible for is this part here in the middle. If I drew this out to here, that's called our radius. The radius of our cylinder. That part there, little r, stands for the radius, so we'll write in radius for you. So we need to be able to speak about what these things are. So the radius is half the diameter, right? And the bases of the cylinder are circles, right? The base is a circle, and the top and the bottom are circular. Lateral area. Lateral area is the same, not the base. Lateral area is the same as it's been so far for all of our other solids that we've been talking about. It's the area around the figure, not including the bases. That's what it says right there. The area around the cylinder, not the base. I know it's sloppy, but that's what that says, not the base. So when I have a picture of a cylinder here, and here's my cylinder here, there and there. So I want to calculate the lateral area is the area around this thing, not including the bases. So this stuff right here, if I was looking straight at it. Okay? So if you think about it, no. Well, just around the edge. It's like, think of a soup can, okay? And the label of the soup can is only around the actual sides, right? The label of a soup can does not include the top and not include the bottom. In fact, the soup can example is really good. If you cut the soup can label straight up and down and then unwrapped it, what would you have? What shape would it make? It'd make a rectangle, wouldn't it? Right? If you cut that label off of a soup can and laid it flat on the table, it would make a rectangle, right? Yeah. So we're talking about then the lateral area. So then how are we going to calculate that lateral area from? So that being said, if we took this and we unwrapped it, if we cut down the soup label and we unwrapped it, right? We have to go all the way around. What's the distance all the way around?
360.
No, the distance. What's the name for that thing called? All the way around. The circumference, right? So the circumference has to be a part of this formula. So we're calculating lateral area. The circumference of a circle is what? 2 pi r, right? Now, we also have a certain height to this cylinder. So if we multiply by the height, that will give us the lateral area, 2 pi r. Remember, after all, this part right here is just the circumference. And this part right here, of course, is our height. Okay, so lateral area of a cone, sorry, not a cone, a cylinder. I keep wanting to jump to the cone. The lateral area for the cylinder is the circumference times the height. Because remember, if we cut that label and unwrapped it, we would have a circumference, and then we just multiply by the height. Okay, then how does that differ from total area then?
Total area plus area.
Very good. It's going to be the lateral area plus the area of the base. But how many bases do I have? I have 2 bases, right? I have a top and I have a bottom. And each base is what figure, what shape?
Circle.
It's a circle, okay? So the lateral area, we already know the lateral area was this, 2 pi r h. That's the lateral area. Now I'm going to add to that 2, because I have 2 bases. What's the area of the base since it's a circle? What's the area of a circle? Yeah, pi r squared, right? Pi r squared. Base area. Capital B is base area. Perimeter is circumference, okay? So this is the one that we're going to use for total area. It's going to be this one right down here. Okay, volume of a cylinder. I've highlighted the base for you. There's my cylinder down there. So the volume then has to be the area of the base times the height. The area of the base times the height. That's it, right? The area of the base times the height. Well, what's the area of the base? It's a circle. Do we know the area of a circle? Yeah, it's just pi r squared, right? And then multiply that times the height. So you could write it as h pi r squared. That's our total volume. H pi r squared. Okay, we're going to talk about all the parts of the cone and one idea here, okay? So the first thing we're going to do is we're going to talk about how do we talk about the height of the cone. Well, that's going to be the altitude. We drop from the vertex right to the center, and it's perpendicular to the base. That counts as our altitude slash height. Altitude slash height.
I don't really get what you mean by perpendicular.
Perpendicular means right angled straight up from the base.
It's like an illusion.
It's an altitude, right? Altitude is the shortest distance from the vertex down to the base. Now, what do you think this piece is called here?
Radius.
Very good. That is the radius. You got it. What do you think this blue line here is called? Yeah, that's our slant height. And that's going to be counted as L. Slant height. Okay, so let's talk about the lateral area. The lateral area for a cone is going to be pi r times the slant height. Pi r L, where L is the slant height. So that means that the total area of the cone has to be the lateral area plus the area of the base. And I only have one base in this case. Well, the lateral area is pi r slant height plus what's the area of the base? It's a circle, so what is it? Comes up again and again. Pi r squared. That's the total area. So if I was going to paint this cone on the outside, so paint all the way around and paint the base, pi r L plus pi r squared. L stands for slant height. Okay? And then lastly, let's talk about volume. And Alessandro, you are totally right. It is 1/3 the volume of the cylinder. So 1/3 pi r squared h. Okay, here's what we're going to do. I've got two figures. I have a cylinder on the left, and I have a cone on the right. What we want to calculate is the lateral area for both figures, the total area for both figures, and the volume for both figures. Okay, that's what I want you guys to do. Alright? I want you to try it on your own, working with the person sitting next to you, and I have the answers. You can check them with me. Ready, set,